You don't actually need Claude, ChatGPT, or Gemini to use a powerful AI model. You can download one to your own computer, disconnect from the internet, and keep talking to it. No API key, no per token bill. And with a truly local setup, your prompts can stay on your machine. But installing a local model is the easy part. The difficult part is choosing one your computer can actually run. Download the wrong model, and you could wait to a 20 gigabyte download only to discover that it barely responds, or doesn't fit in memory at all. So in this video, I'll show you how to run your first local AI model, how to choose the right model for your RAM and VRAM, what terms like 9 billion, Q4, and GGUF mean, and how to avoid the mistakes that make local AI painfully slow. By the end, you'll know exactly where to start on your own PC or Mac. Let's start by actually running one. If you're completely new to local AI, the easiest place to begin is probably LM Studio. It works on Windows, macOS, and Linux, and it gives you a normal graphical interface instead of making you learn terminal commands first. The basic process is simple. Install LM Studio, search for a model, download it, load it into memory, and start chatting. That is the entire process. LM Studio can even estimate how much memory a model will need before you load it, which will save you a lot of guessing. But don't download a random model yet, because whether it runs well depends on three things: your computer's memory, the size of the model, and how heavily that model has been compressed. Once you understand those three things, choosing a local model becomes much easier. When you use ChatGPT or Claude, your prompt normally goes to a model running in a data center. With a local model, you download the model files and run them on your own hardware. Once everything is downloaded, the model can work without an internet connection, and your prompts do not need to be sent to a cloud AI provider. That makes local AI useful for private documents, confidential code, offline access, experimentation, or simply having more control over the model you use. But there is an obvious trade-off. OpenAI, Anthropic, and Google have enormous data centers. You have a laptop. So the first real question is not whether your computer can run a local model. It probably can. The question is, which model can it run well? Before downloading anything, check two numbers. How much system RAM does your computer have? And if it has a dedicated graphics card, how much VRAM does that GPU have? On a Windows or Linux PC with a dedicated GPU, VRAM is usually the most important number. More VRAM lets you keep a larger part of the model on the GPU, which normally gives you much better speed. If the model does not completely fit in VRAM, tools such as LM Studio and llama.cpp can move some of it into normal system RAM and use the CPU too. That may allow the model to run, but it can also make it much slower. On Apple Silicon Macs, the setup is different. The CPU and GPU share the same unified memory. That can make Macs with 32, 64, or more gigabytes surprisingly useful for larger local models, because the GPU is not restricted to a separate 8 or 12 gigabyte VRAM pool. But macOS and your other applications still need memory, so a 32 gigabytes Mac does not give all 32 gigabytes to the model. You can also run a model entirely on the CPU. It works, but larger models will normally generate text much more slowly. This leads to the first rule of local AI. The largest model your computer can technically open is not always the model you should use. A smaller model that responds immediately can be much more useful than a larger model that makes you wait for every answer. Now let's decode the names. When you see 4 billion, 9 billion, or 27 billion, the B usually refers to billions of parameters. So a 9 billion model has roughly 9 billion parameters. Larger models are generally more capable, but they also need more memory and more computing power. Bigger does not always mean better. A newer, well-trained small model can beat an older, larger model, but parameter count is still a useful first estimate of how demanding a model will be. The problem is that a 9 billion model stored at 16-bit precision would need roughly 18 gigabytes just for its weights. That is where quantization comes in. Quantization stores the model's numbers using fewer bits. When you see Q8, think roughly 8-bit weights. When you see Q4, think roughly 4-bit weights. Lower precision means a smaller model and lower memory use, although aggressive quantization can also reduce quality. For example, Ollama currently lists Qwen 3.59 billion in Q4KM at around 6.6 gigabytes, far smaller than the same parameter count at 16-bit precision. For a beginner, a good 4-bit version is usually a sensible place to start. It often provides a strong balance between size and quality. You will also see GGUF everywhere. GGUF is simply a common local model file format used by llama.cpp and many apps built around it. You do not need to understand its internals to get started. So now we can answer the question that actually matters. What model size should you download? There is no perfect chart that works for every model because architecture, quantization, and context length all affect memory use, but these are useful, conservative starting points. If you have around 16 gigabytes of system RAM and no strong dedicated GPU, start with a 2 billion or 4 billion model. Once that runs well, you can try an 8 billion or 9 billion quantized model and decide whether the speed is acceptable. With around 8 gigabytes of VRAM, start somewhere between 4 billion and 9 billion at a sensible quantization such as Q4. Qwen 3.59 billion's Q4 package is around 6.6 gigabytes, but remember that the model needs extra memory while running. A 6.6 gigabytes file is not a promise that every setting will fit perfectly in 8 gigabytes of VRAM. With 12 to 16 gigabytes of VRAM, models around 9 billion to 12 billion become much more comfortable, and you have more space for context. With 24 gigabytes of VRAM, quantized models in the high 20 billion to low 30 billion range become realistic. For reference, Ollama currently lists Qwen 3.627 billion at around 17 gigabytes and Gemma 431 billion at around 20 gigabytes in their default packages. If you remember only one rule, make it this: start smaller than you think you need. If it runs quickly and you still have memory available, move up. That is much easier than downloading the biggest model first and trying to work out why your computer suddenly feels broken. By the way, comment your GPU, VRAM, and system RAM below. I'm curious what hardware everyone is using for local AI, and it may help me decide which setups to cover in the next video. Now we can return to LM Studio and choose a model properly. Search for the model family you want, and look at the parameter count and quantization before downloading. For a first test, choose a 4 billion or 9 billion model that comfortably fits your hardware, preferably around a good 4-bit quantization. Then check LM Studio's memory estimate, keep the context length modest, and load the model. Once it is loaded, you can chat with it almost like a Claude AI. If it responds quickly and your memory usage looks healthy, you can test a larger version later. LM Studio can also expose the model through a local API, so your own applications can use it through localhost instead of sending each request to a cloud provider. But if you prefer the terminal, there is an even more popular option. Ollama works on Windows, macOS, and Linux. After installing it, a single command can download and launch a model. For example, Ollama run Gemma 4. If that model is not already on your computer, Ollama downloads it and starts the chat. Ollama also provides a local API, which is why so many local AI tools integrate with it. But there is one detail you should know. Ollama now offers cloud models as well as downloaded local models. If privacy or offline access is your reason for running locally, check the model you choose. A cloud model still sends the request away from your computer. For a truly local setup, use a model that is downloaded and running on your hardware. The Ollama PS command can show what is loaded and whether it is using your GPU, CPU, or a mix of both. At this point, your model should be running, but two settings can turn a good setup into a painfully slow one. The first is context length. Context is the information the model can keep available while answering, including your prompt, conversation history, documents, and code. A model may advertise 128,000 or 256,000 context, but increasing context also increases memory use. So, a model that fits perfectly during a short chat may run out of VRAM when you load a large codebase. Ollama automatically adjusts its default context based on VRAM, which shows how significant this trade-off can be. You can increase it, but maximum supported context is not the same as the context your hardware can run comfortably. Whenever someone tells you that a model fits in 8 gigabytes, ask, at what context length? The second problem is CPU offload. If the entire model does not fit on your GPU, part of it may move into system RAM and use the CPU. It can still work, but generation may become much slower. Local model speed is often measured in tokens per second, but you do not need to chase one perfect number. What matters is whether the model feels fast enough that you actually want to use it. The best local model is not the largest one that launches, it is the best one that runs well on your hardware. Local AI makes sense when privacy, offline access, control, or heavy repeated use matters to you. Maybe you are working with private documents or confidential code. Maybe your internet connection is unreliable. Maybe you want to experiment with different models and settings, or build tools without paying an API for every token. Cloud AI makes more sense when you want the strongest available models, the easiest setup, and no hardware management. And local AI is not completely free. You pay through hardware, electricity, storage, and setup time. You may also accept lower model quality than the best cloud systems, so this is not about local always being better. It is about having another option, one that you control. So here is the entire video in a few lines. Check your RAM and VRAM. Start with LM Studio if you want the easiest graphical setup, or Ollama if you prefer the terminal. Choose a 4-bit model smaller than you think you need. Keep the context modest. If it runs quickly and you have memory left, move up. And if privacy matters, confirm that the model is actually running locally. Once you understand those rules, terms like 9 billion, Q4, GGUF, and GPU offload stop looking complicated. They all help answer one question: how much AI can this computer run comfortably? If this guide saved you from downloading the wrong model, leave a like and subscribe for more practical local AI videos. In the next one, we can go hardware by hardware, from a 16GB laptop to a 24GB GPU or a high memory Mac, and choose the best model for each setup. I'll see you in the next one.